Let's look at finding limits graphically. So far, when we have found limits, we have looked at finding limits algebraically. We've used infinitesimals to help us find the limit. But we've also seen the connection between the value of the limit and what happens on the graph. So now let's try to look at the graph and find the limit. So we're doing it backwards. Before, again, we've looked at the limit and how that affects the graph. Let's look at the graph to come up with a limit. So we have the graph of y equal f of x here before us. In the first part, part A, we have the limit as x goes to 2 of f of x. So the first thing you should do when you want to find one of these limits graphically is to identify the place in the graph with the appropriate x coordinate. In this case, it's x goes to 2. Now, I'm going to put little squiggles here so that you can, with arrows, so that you can see what I would be pointing to if I was doing this live on a whiteboard. But these squiggles aren't necessarily part of your procedure, although they could be, and they're certainly not parts of the graph. But again, here I want you to point to where the x coordinate is 2. Now we see here that we have a hole. And we recall that in a hole, we have the x and y coordinates of the hole are where the x is going to for the x coordinate, but the y coordinate was the limit. So since the y coordinate of this hole in the graph, that point would be 1, then the value of our limit must be 1. So again, that's where we had a hole. Let's try that for x goes to 4 in part B. So here I'll do my little squiggly arrow to show where we are, where the x coordinate is 4. And notice here we have a vertical asymptote. So when we have a vertical asymptote, that's where we had an infinite limit. And in this case, our values must be going positive infinite, according to the graph. So that means our limit must be positive infinity. Let's take part C, limit as x goes towards 6. Now here we see that there is a gap or a jump. We've described it using either word. And the idea here is that the limit is different from each side, which means that our limit, our two-sided limit as x goes to 6, does not exist because it's different from each side. Let's look at the limit as x approaches negative 2. Well, as I approach negative 2, I see again a hole in the graph. The x coordinate there is minus 2. The y coordinate is 2. So I'm going to go ahead and write the limit as that y coordinate of 2. Now, the fact that there's that extra point there is irrelevant. Recall that the value of the function where we are taking where x is approaching is irrelevant in our limiting process. So the fact that f of 2 is equal to 3, that's what our filled in dot there is at the point minus 2, 3. That fact is irrelevant and has nothing to do with the fact that we have here that hole in the graph so that we can evaluate the limit as 2. Let's move on to part E. We need here to look at the x coordinate of minus 1. So that again gives us a vertical asymptote. But notice this time we are approaching positive infinity on one side, minus infinity on the other. It's not the same on both sides. Therefore, again, this limit does not exist because, again, it is different from each side. On part B, we could say plus infinity for that two-sided limit because it was the same. It approached that asymptote upward on both sides instead of upward on one side, downward on the other. Let's move on to part F then, and we'll look at the one-sided limit. Remember, the plus after the minus 1 means that we're taking the limit as x goes to 1 from the right. So this time I'll draw my little squiggly coming from the right toward -1. So that again, in this case, if we look at the values of the function, what's happening to the function as we go from this right side, it's going to -infinity. So again, on that vertical asymptote, so that would be our limit. However, when we go toward -1 from the right-hand side, look at what happens to our values now. Our graph from this side of our asymptote is going upward on that vertical asymptote, so that means our limit must be positive infinity. Moving on to h, we have limit as x approaches 6. From the right, we already established that the two-sided limit didn't exist, but from the right then, it appears that our values, our y-coordinates, are going toward 0. Right, it looks like we have the point 60 that we have arrived at from the right. But from the left, if I approach 6 from the left, I'm approaching that hole with a y-coordinate of 1, and therefore my limit is 1. The last limit then to look at is the limit as x approaches a positive 1, so that's here. And our y-coordinate associated with that point is 0 from both sides. It looks as if it's a hole, but it's like it's a filled-in hole. And remember, the value of the function there is irrelevant, so whether the hole is filled in or not, it's the same thing as if it was a hole. It's the y-coordinate that gives us that limit. And so that is a summary of the different issues involved in finding these limits graphically.